Hi there. This is the beginning of the lower 6 AS chemistry. I'm going to start with AS physical chemistry. Right, and this you can see is the atomic structure. You can see the physical chemistry. Okay, it's the first part. You can start with 1, 2, 3. So we're starting from the very beginning. Okay, and you see the atoms, molecules, and stoichiometry. The topic illustrates how quantitatively, okay, relationships can be established when different substances react. The term relative formula mass, all right, for all compounds will be used for all compounds, including ionic. So this is very important that we state here first. Okay, relative formula mass. Last time, this one is used only for ionic compounds. So relative formula mass, you can see here, relative formula mass, right? Used for all compounds, which means the word compounds here, must understand, refers to covalent, as well as including ionic. So our definition will change a bit from the old one I gave you, okay? So never mind. So you must be aware of what the syllabus say, because the marking scheme will go according to the syllabus here, okay? So here's quantitative. See, the other word, a few words you must understand. Quantitative means how much. Qualitative means what is it? Quality. Quantity means how many grams, how many substance there, numbers. Okay, this will be numbers. Okay, quantitative relationships between the different substances. Okay, so we're talking about mass, numbers. Okay, all right. Learning outcomes. Guys should be able to. Now, this whole thing here, all these things here, today we want to do this one here. But before that, I want to go back, track back the same. Now, they say atoms. Okay. Molecules, and the word stoichiometry. I wonder whether how many of you know what I mean by stoichiometry. Later I'll ask you again. Okay. Now the word atoms here refers to mainly elements. What elements? Well, elements are basic units of substances there, right? Carbon is the element, hydrogen is the element, oxygen is the element, right now. Molecules can be referred to elements as well as compounds. Okay, I assume you know all this because this is Form 4. Okay, when the elements are called molecules is when they are diatomic. For example, well here, O2, group 7, F2, Cl2, Br2, etc. H2. There isn't much. O3. Of course, there is your astatine, At2, and of course, there's a nitrogen. Okay, and so forth. All these are referred to as molecules, but the elements. Of course, the general thing, compounds means, well, that means the substances which are chemically 2 or 3, right? Compounds refer to here 2 or 3 different what? Different elements. Elements chemically combined. Okay, chemically combined. Okay, the words are very important. Chemical combined means they cannot be separated easily by physical means. Like for example, if you mix iron particles and sulfur elements, and you don't heat them, you mix them up in the mixture, you use a magnet, you can separate them, isn't it? But if you heat them, they undergo a reaction called a chemical reaction. There's something like chemically combined. Once they turn to iron sulfide, you cannot separate them easily. Magnet cannot separate them already. Okay, they change the Fe2 plus and S2 minus. That's what it means. Okay, now these are all Form 5 things, Form 4, Form 5 things. Okay, so I want to bring your attention to the terms that you use here. Of course, now stoichiometry means that actually, the ratio of things in a balanced equation. For example, okay, carbon plus oxygen gives you carbon dioxide. Okay, you balance the equation here is 1 mole and 1 mole. Hope you know is 1 mole here. This the stoichiometry is 1:1:1. Here it means these are the ratio of the numbers in front of the elements in the compound. Okay, this is stoichiometry, a balance equation. What's the balance equation? Okay, these are just the overall. Right now, before we go into relative mass of the atom here, okay, I want to talk about atoms first because a lot of question comes on the raw composition of atoms. Okay, now I'm going to use another part. I just learned to use blank zone. Okay, now remember, right? Atoms, right? They're the basic units of elements. Okay, basic units. Okay, used to say the indivisible part of an element, but now they can be divisible into, you know, protons, electrons. They split the atom, but that's old language. So atoms are made of, you know, right? It's a nucleus here, right? It's called a nucleus. Okay, and nucleus is where you can find the protons, right? In Form 5, you draw a circle like that and put a positive sign here. And the neutrons. Just draw a circle with no charge here. Okay, this is where you find the nucleus. Is in the center here. They are held together by some force called the binding energy. Okay, don't worry about that. Okay, and of course there is electrons. Now they ask you know where they are. No, I tell you. Okay, it's not very good circle. Okay, this is a circle here. Okay, these are, well, orbits or electron shells. All these are called. In form, I'm talking about Form 5 or Form 4. Okay, this is called electron shells. They will ask you. I'll show you afterwards. Electron shells, or they call electron orbitals or electron orbits. Okay. All these terms are used. Terms are very important because they help you to answer questions and they will give the mark according to that. Okay, I will take down the time first. I must stop on time. 12, 15. Okay. Now, all right. So another thing, of course, is how do you represent an element? Okay. Now, elements are represented by, for example, carbon. Okay, carbon, you know, this now very important. They ask you, okay, about the position of the two numbers here. Very important. Some books put differently. Even some, you know, according to the data bullet, they write differently. But look at exam questions. Okay, the bottom part here is called the proton number, or they call it atomic numbers again, but they normally call it proton number. Okay. Remember the bottom one, normally the smaller one, or they call it atomic number. So the atomic number is the one that will define what the substance is. The top one is called the mass number. Okay, or now commonly called the nucleon number, because all find nucleus, nucleon number. Okay, right? Or the atomic mass. The total mass, mass means how much they weigh. Okay, the total. Okay, now, so all these are top one here. For example, carbon is 6 here, and it's 12 here. Now here, if there's no charge, here we'll write the charge. If there's no charge here, right, empty here, if it's no charge, right, no charge, right, if it's empty here, is assume no charge, there's empty. If there's positive, that means it's positive. If there's negative, there's negative. Okay, so you can see it by the thing here, right? Okay, now let's go and see the overall. I want to go to that first because this is Form 5 work. Okay, I want to show you how these kind of questions are asked. Okay, now they normally come. Okay, let's look at a symbol first. Okay, page 323. Okay. 323. Now these are your notes. You can find it in my website. Okay, it's here. X is a particle with 18 electrons and 20 neutrons. Now, when this, you have to read the question carefully. It's a particle. So now X. Okay, so there's no charge here. charge is 0, which means what? Number of protons is equal to the number of electrons there. Okay, it's a particle, right? A particle which actually means an atom lah. Okay, right? X here. So X, right? So 18. Now remember, if there's charge 0 here, 18 electrons equals to 18 protons. Yeah, right? So you put 18 here lah. First thing. See? And of course, up here, as I said, the mass number is actually the number of protons plus the number of neutrons. Okay, so there's 20 neutrons here plus 18 protons here is with 38, isn't it? See? Now remember, see, okay, this is how Cambridge writes it. Okay, now here is the symbol, argon. 18 represents the atomic number or the proton number. Top here is the mass number or the nucleon number. I'm using these phrases, these words here, because they come out in exams, not for fun. Okay, now here 20, 40. Now this is charge 0. So since it's a particle, charge 0. Okay, now here is calcium 2 plus. If I draw bigger, okay, if you can see 20. Here's 40. This is actually Form 5 book. I'm just refreshing your brain a bit if you have any. Okay, 20 means 20 protons, right? Right, neutrons, okay, 40 minus 20, right? 40 minus 20, give you what? Give you 20, so 20 neutrons. How many electrons are there? Now remember, 20 protons equals to 20 electrons in the atom, isn't it? Right now, since it's positive 2, right now, that means it has got 2 protons more. That means 20 protons, 20 positive, right? Plus how many electrons will give you positive 2? You do it like this, Form 5, isn't it? So X how much? X equals to minus 18. So this will be 18 electrons. Right? Of course, this fit this 18 electrons. 20 protons. Right? That's all. Okay? Which particle here? Okay? Now the particle can be atom or also an ion. Particle means the smallest atom, smallest. Okay, so here you got what? You got, they ask you only for this, 80 electrons and 20, which is correct, isn't it? So this is correct. This is also correct. Potassium. Okay, potassium here. I got 19 protons. Okay. How many neutrons? 39 minus 19? 20 neutrons. Okay, now how many electrons? Remember, right? I got 19 protons. Now plus how many electrons will give me positive 1? Right? Positive 1. That means how many here? So equals how much? Plus 1, you bring another 1 minus 19. How much is it? Minus 18. So there's how many electrons? 18 electrons. So X, the particle, can be atom, as I said, or can be ion, right? Particle, if it's a molecule, that means it's the smallest, it means the whole molecule itself. So these two conditions only, they didn't say number of protons, no, okay? 18, 20. So A, 1, 2, 3. Okay? So these are the kind of things that you should have done in your Form 5. Now I'm just giving a revision. Okay, now these are called dealing with atoms. It's not the syllabus there. They assume you know, and it comes in exams. Okay, now let me show you the table. Okay, the first table, the simple table. Okay, we look at 415. 415, before I go to the hardcore stuff. Okay, this is also another one here. I should have. Never mind. I can. Never mind. Because you know that they in your data booklet, actually they provide you with the mass of electron and things like that. But you should know in Form 5 you actually memorize it. Now there is one here. I think. Let me just go. Never mind. I better go to it. I'm going to say I bluff you. Okay. Don't know why there are a lot of ants today. Never mind. Now there's one question here. There's 360. Let's look at 360 first. 360. I want to get the number 360. Not this one. 360. Okay, let's do 360 first. Now this is good. Now this is quite simple. Okay, complete the table to show the composition of some atoms or ions. Okay, these are particles. Okay, so for example, lithium here. This is famous form 5 IGCSE. Okay, lithium. Now you can look at your data booklet and see lithium. Right? I think I better go there. I tell you. Okay, let's look at plus. Tab. Wrong tab. One this. Tab. This line is not very good. I'm sorry about this. Okay. Now you can look at this. Okay. Now we're going to get the data booklet. This is what you will get in exams. Okay. Data booklet. You can see here. Blow it out first. How to blow the idiotic thing? Okay. Well, okay. It's right at the end. Okay. Okay, not so high in. Okay, now here is a data bullet. Okay, now I'm going to reverse it. How to reverse it? Okay, reverse. Okay. Okay. Where's the good? Okay, here we are. Now you see these fellas are idiotic. See, they put a small number on top and a big number on the bottom. See, but actually in exams, all right, they are always like, for example, I'll put the marker first. Color. Wait. Okay, for example, okay, we took some simple chromium here. See. So we see R, the big number is about 52, and the small number is 24. Now this is how they are in exams, but here they tell you the different one. Idiot, I tell you, it makes it confuse you. But there's a reason for it, because they want to label it 1, 2, 3, 1, 2, 3, 4, 5, 3, 4, 5, 6, accordingly like that. That's the reason why. But in exams, it's always the big number on top. Make sure you know. Okay. This is important. Don't write any way you like. Okay, this is not like your father's house kind of thing, Right? Okay, I'm going to turn it back. First, I want to look at something else. Okay, turn it back. Turn it back. Turn it back. I see. I tell you, this computer is really ridiculous. How to turn back? We first, okay, then we go back. Right? I want to show you something. Okay. Now in a data booklet, they will give you as I said, the value in the first part here. Okay. Let's see. Okay. Now this is a data booklet. Later, a small booklet which should be given in exams. In page 1, they give you all this nonsense here which you need to know. Not nonsense, but you need to know. See now, the rest mass of proton, means of a proton. Now this is the actual mass now. Okay, 1.67. That's about 27. Maybe it's the first time you see it, but never mind. You need to know. Mass of the rest mass of neutron is the same as 1. Okay, normally we say 1:1. No, it's an idea of relativity, relative. Okay, right? This is a rest mass of electrons. Okay, it's on here. All right, you put down here. Okay, right? The charge and so on. This is given here. Now you compare these two. If you want to put the value Okay, right? This one is approximately 1 over. This is 1 over. I think it's 1864. Yeah, around there. Okay, so yeah, right? If this one, you can actually calculate the color here, right? And then do the calculation. Okay. 9.11 divided by 1.67. Oh, yeah, I said that way wrong. Okay. It's about 0.005 something, like 54 something. Never mind. Okay, you go and divide it, and you can see the value here. Now, this is what they ask here. All right. Now, first of all, now let's come to this question first. Okay, lithium, they put in nucleon number 6. You know, atomic number 3. Well, which means you say that if you want to draw this out here, my pen is here. Lithium. Okay, 6 and 3. Sometimes there's a 7 no, right? You look at here. All right, look at here. Okay, look down here. Lithium. Because of isotopes, see? Right, 6.9 is it? It's not here. 6.9. So it's 7 no. Okay, 6.9 is it? I need to do something. I say this. Pen, come on. Okay, see? Right. Normally lithium is 7 and 3. 6 is because, as I said, later you find that the isotopes. Okay, so don't care first. So you do as the question tells you. Okay, so it's the one here. So number of protons, of course, atomic number is it? So they use the atomic number here. Okay, instead of proton number. Okay, so you need to know proton number. I'll show another question here talk about proton number. Okay, afterwards, okay, number of protons, of course, 3. Number of neutrons, 6 minus 3 is 3. Number of electrons, since it's the element, which means not iron, it's with 3. No, cannot. I say overall charge, I say +1 here. So it's +1 here. So 3 protons, 3 neutrons, and if 3 protons plus number of electrons equals to +1. So +3 plus x here equals to +1. So x equals how much? +1 minus 3 equals to -2. So 2 electrons there. Yeah, so it's 2 electrons. Okay, can you work it out? Okay, the rest is the same. So the overall charge here will tell you. Okay, let's one here. Okay, let's go down here. 54. So you got x here, y. 54 is a nuclear number on top of 54. Okay, atomic number is 26. That means the element is defined by this number here. All right, proton is also the same one. Okay. Okay, so number of electrons here is 24. That means less electrons here, so it's +2 here. That's all. Because this is plus 26 minus 24 over is +2. So what's the number of neutrons? Neutrons, of course, will be 54 minus 26. How much is it? Carry here is 8, 4, 28. So here's 28. Okay? Right? So what is the so the name now of the substance, you of course take from number of proton from here or here. So you go to your data booklet, right? And you see for what number is it already? 26. Okay, what is 26? Okay, 26 on top here, that is to find iron, iron. So yeah, so the iron here is iron. So that's what you must do, and you put in iron. Okay, I will let you finish the rest of it yourself. Now, this is what came out in Form 5. Right? Now, Form 6, now this question here is a bit, tricky in a sense. I just do it one for you, okay? Here is on the table, page 4 and 5. You know why? Come, it cannot give me the page now. Okay. 4 and 5. Okay. 4 and 5. Can't give me the one. I'll go myself, man. Okay, out here 4 and 5. Here, right? It used to give me the page. I don't know why now it can give me the page. It's crazy computer thing. Now okay. The model of the nuclear atom was first proposed by Ernest Rutherford and so forth. This model, the basic results, and so forth. Okay, okay, goal. Okay, so complete a table with the information of 2 particles, right? 2 particles. These are particles in an particles means the smallest substance in an atom. That means the particles of an atom are the 3 actually called subatomic particles of gold. Remember, they say here gold is how much? 1 AU. Gold price going up. 197. Okay, right? Now the mass of the electron is 0.005. Okay, remember, right? This is the normal in Form 5. You learn this. Okay, that means you look at the original one. If you just now you were to look at this part here, you can find out the ratio. Okay, if you ratio it, you will give you around here. You can do it one in exams. You better do it now. Don't exam then. Don't try it. You idiot. So you look at here, right? Here, right? The mass down here. See, these 2 are taken at 1 and 1. See now? Okay. So you compare it with the proton. Doesn't matter proton neutron. So it is 9.11 times 10 to the power of minus 31 divided by, okay, compare how many times this is compared to this one here. 1.67 times 10 to the power of minus 27 is about 0.0000, I think 54 something. Okay, so normally they take it as 0.00243, 4 zeros here. You can see here. 3 zeros here. Okay, and 5. So neutron is relative is 1 here. Okay, right? So they ask you for the relative. It means relative is comparatively. It is comparing. Relative means to compare. Okay, every word there's a meaning like compare. Right? Compare with each other. Compare this one here. Right? Normally you compare with the proton one, but doesn't matter. They're all same. Neutron is charged 0 anyway. Right? So this is negative. This is 0 charge here. Location. Okay, now this comes to what? Electron shells again. Right? Electron orbitals again. To be electron shells. I should answer first, shells. This is the nucleus, nucleus, right? The total number, okay, for electrons. Remember this one here, they say 79, right? That means here be, it means there's no charge here. That means it's 79 protons as well. It's not, okay? Neutron, how many neutrons are there? So it'd be 197 minus 79. Understand? Carry 1 here, 8. Carry 1 here, 8, 1, 1. So, yeah? So it's 1, 1, 8. Okay? Now let's look at the marking scheme, okay? Here. It's 18, 18 is the Bundu 18. Sorry. Okay, see now. No. 18 here. Okay, 1, 1, 8. See, electron shell or shells, 0 here. See, 1 is comparatively. Or 1.001 to be exact, doesn't matter what. Because if we take from the data book, it can give quite exact answer. Okay, so you can see this is how the marking shells, electron shells or electron orbitals also can. Right? Now look at other kind of things they ask you, okay? Now we won't go to isotope first, we'll come back to something here. Now here, a different sample of gold contains more than 1 isotope. Right? Of course, isotope means same element, different atomic mass, or different number of neutrons. Okay, now here. So just why this different sample of gold has the same chemical properties as a sample of found gold. It means even though they're isotopes, they have a different number of neutrons, but they have the same chemical properties. Why? Because the chemical properties means how they react with each other. Chemical reaction. Chemical reaction is not determined by the protons or the neutrons. It's determined by what? the number of electrons there, right? Because the chemical properties, how they react, how they undergo, they call it chemical reaction. It means a change. It's controlled by what? It's controlled by the number of electrons or number of electrons where? In the outermost shell. Okay? So, right, you can see this now. Look at the answer here. All right. Okay. Okay. All right. Same. Oh, is it the one? Okay. 1C. Correct, okay. So just why this sample go has the same chemical properties, right? Same chemical properties means that they have the same number of electrons there on the outermost shells. You know. Same, because they have the same number of electronic structure, electrons in the structure. Okay. Same number of electronic structure. Very good. Okay. Okay. Normally I say same number of electrons in the outermost shell. Okay. Same number of electronic structure. Or electronic configuration. Same configuration. So all same for all the isotopes, all the time here. Okay, so this is how they ask you for Form 5 ideas basing on Form 6 ideas. Now, I won't go on some more, right? I later got some questions on this. Now let's go to the real stuff which I want to talk about today. Okay, now here. Okay, I finished all these things, and now come to definitions. There's a key thing in IRAS. Okay, candidates should be able to, number one, relative masses of atoms and molecules. This is talk about this whole thing, okay? Right? Define and use the terms relative atomic. Actually, you got relative atomic mass, or relative isotopic mass, or relative molecular mass, or relative formula mass based on carbon-12 scale. I'm going to use this one here to draw the whole picture, okay? So, a little bit of this. I don't, okay, use it. Okay, now, you can actually talk about here as, okay, all right, atomic structure. Gone already. I have to start again. Okay, atomic masses. Okay, now here they are relative here. So there are a few ways to talk about it. The first one, the one is called the relative atomic mass. Secondly, they talk about relative isotopic mass. Next, talk about relative molecular mass. Lastly, they talk about relative formula mass. Remember, this is normally for ionic, but now they don't care really. Normally for ionic compounds. Okay, but now they include plus also covalent compounds now. You can see later in the marking schema. But this one normally is just for covalent compounds. Okay? And you will know that these two, right, are normally for compounds. Of course, in this case, relative molecular mass can be for elements. I told you already just now. Elements which have got like Cl2, diatomic or triatomic, O3, O2, what is this? P4, S8, can also, okay? Okay, H2, right? This one are strictly for elements. Okay, this one you say, now, why I use the word relative? Okay, I'm going to use a different thing, okay? Relative, blue ink, okay? Why relative, the word relative? Why is it relative? Okay, why use relative? That means compared to. Relative basically means compared to, okay? Compared to, in comparison, compared to. Because they are so small and so light, to put a value, an actual gram or kilogram is so small, see? So to make the number large enough for us to compare, for example, I weigh 0.0002 grams. Oh dear, so big. If another person weighs 0.001 gram, that means I'm 2, he's 1, no comparison. So you compare, the idea here is when you compare to what? So in your Form 5 learning, they always compare the bottom one. So one of the most stable isotope, one of the most stable element, which is more common, is carbon 12. Okay, it's just 6 carbon 12 now. Because it's carbon 13, carbon 14, 15, 16, but the one carbon 12, because carbon 12 about 99% or whatever. Okay. So this one is found in the whole, because already organic one. Okay, so 1/12 times mass of one atom of carbon 12, where you must say, now this is Form 5 definition, where carbon 12 is equal to what? 12 units. Scientists are very good. Exactly. Which means if this is the case here, 1/12 times 12 is equal to how much? 1. Okay, this is AMU, atomic mass unit kind of thing. Okay, now. So that's the idea. Right, now let's look at the definitions, okay? Definitions. Okay, now I'm going to maybe go back to that part there. Okay. Right, now if you look at my notes, there are 4, right? I'm going to look at my notes now to make it easier for me, right? So I've done this right, nuclear number, all the things. I want to show you the idea of proton number. The word proton number comes out. Okay, page 30. Okay, now if I come up from there, very good. Okay, so proton number. Page 30. Come give me page 40. Okay. See here? See? Define the term proton number. There you go. Okay? Not atomic number. Proton number. The answer is, of course, you look at carefully here. Okay, this 06, just to, so I don't lie to you lah. Is it here? Okay, 06 number. Okay, proton number. See? The number should be the total number. See, should be here. It's not here. The total number of protons in the nucleus, you must use the word nucleus, otherwise no marks. Okay, so the first one, of course, is on here. It's the total number or the number of protons in the nucleus of an atom. If it's not there, no marks. Okay, so the 2 points here, total number of protons. I prefer total number to be exact. Or the number of protons in the nucleus, number 2. Where? Can be nucleus, or you can say, oh, in the orbital shell, but that's rubbish, isn't it? Okay, so in the nucleus is very important. Now the second question here, okay, why is the proton number of the atom of the element usually different from the nuclear number? Normally it's different from the nuclear number. Why? Because the number of protons and neutrons are not the same, is it? Right? 6, let me see. 06. I just got 06 now. Okay, here. Why? Right? Okay. The nucleus usually contains protons and neutrons. Okay. Oh, they want this one. The nuclear number of should be correct. Okay. The nuclear number is made out of number of protons plus number of protons. So cannot be the same, is it? But when are they the same? When are they the same? Example. When the number of neutrons is 0. When it is 0, hydrogen. See now, same. So this is of course number of protons. This one is equals to the nuclear number, say, or the mass number, say, which is N plus P. Equals to 1, same. So this is obviously 1, because this will define what hydrogen is, and of course this is 0, isn't it? So it's the same only for hydrogen, the rest of no. That's why hydrogen is called a proton. Okay? H plus is called a proton. H plus means what? 1 proton, 0 neutron. How many electrons? 0 elect. So it's called proton. Okay? So these are the things they will ask you in English terms. Okay, now let's go back to here. Okay, I talked nothing already there. Question 3. Right, now we talk about definition. So let's say here was the proton number, okay, or neutron number, proton number, or atomic numbers, okay. Number of protons found. Yeah, I put on especially for this because I look at the marking schema. Must teach correct the marking schema. I don't care what the book says. One, number of protons found in what? In the nucleus of an atom. Mass number, okay, or the nuclear number, they use more nuclear number. They use a more favorite number. It's a total number of protons and neutrons found where? Also say in the nucleus of an element. Okay, isotopes. Favorite question. Always ask one. There are about 10 times they asked already for the past 10 years or so. Right? It's atoms of the same element. Atoms mean the smallest particle of the element. The smallest particle of a molecule is called a compound is called a molecule, isn't it? Right? Atoms of the same element. What will define the element? The number of protons. Okay? For example, hydrogen. Now here, hydrogen is 1, 1, 1. So we got 1 proton here. I'll put up here. Okay? All of them got 1 proton. 1 proton. All the 3 got 1 proton, but 1 proton, okay? But they all got, all of this here got different number of neutrons. So 0 neutrons. So 1 neutron. It's got 2 neutrons. So but different mass number. Different mass number, or they call it different nuclear number. Okay, nuclear number is more and more used these days. Nuclear number. Is that clear? Or different number of neutrons. Okay. They possess the same chemical properties because the same number of electrons in it. Or they say what? The same what? Electron configuration. So this is the better word. Okay, from electron configuration. Okay, a same number of total electrons. Okay, so there are 3 isotopes here. You can see hydrogen is protium, deuterium, and tritium or tritium. Now this 2 and 3 are cause of heavy water. Okay, definitions now. What other definitions here? Okay, after we go into the past question, I want to finish all this. Okay, relative atomic mass. Let me explain first. Okay, now the word relative means I say here. The word relative here means that it's comparing. Compared to what? Okay, comparing. Compare. Okay, atomic here it means element. Have to mean element. The smallest particle of an element is an atom. I said before, the smallest particle of a compound is a molecule. Is it clear? Mass refers to how heavy, quantitative. Quantitative. You have to know all these terms because you quantitative. Yeah. You are supposed to take an English exam, not Chinese exam, not an Arabic exam. You must know all the terms, right? So of an element. Remember, it's of an element. That's why they use the word atomic. It's the ratio, comparison. Normally, for me, for I don't know, for Asians, it's easier to use like, this AR. It's AR means it's called relative atomic mass. Okay, this is the short form. It's relative atomic mass. Okay, equals to, now the relative means I can put a line here. It means I'm comparing it, the ratio of, I'm going to use 2 sides, okay? Okay, here we go. This one here. What is this fellow doing? this one here. Okay, of the element is the ratio, is it? No, okay, the one of the average mass of an atom found in a mixture of natural occurring isotopes. Okay, normally you just put average mass of an atom enough. Okay, I'm going to go back to here. So I put what? It's the average, or the mean is it? Average mass of an atom of the element. Whatever element is it? Element. Okay, I'm going to show you the thing afterwards. Okay. Okay. Right. Let's say if you ask, what is the relative atomic mass of sodium? So I have to put here average mass of one atom, or here one again, of one atom of sodium compared to 1/12 times mass of one atom of carbon 12. Okay, not enough, no. Where you must put down carbon 12 is equals to 12 units. Exactly. Okay, here say 1/12 times mass of one atom of carbon 12, where carbon 12 equals to 12 units what? Exactly. 1 mark, 1 mark. I show you the marking same, okay? Now remember, that is how they answer it. Now let me explain first why they use the word average. Okay? Average because in every element, there's bound to be have isotopes. Isotope means what? Same protons, different neutrons. It means that different masses. Different mass. Let's say I got a class of 10 students, okay? 10 students. They're all clones. 10 clones. Okay? 10 fat lumps. All the lumpy. And you know, after this mother produces 10 children, they look the same. But all eat a lot, but some eat a bit more, some eat a bit less. So the mass may not be the same, right? So out of 10 clones here, one may weigh 200 kilos, one may weigh 201 kilos. 2001. So it must be an elephant. Never mind. Okay, let's put it on here. I just want to give some illustration as well. It's giving trouble already. 2, okay, and one is 200, and one is 202. So it's 204. One is 200, one is 201, and so forth. Okay, oxygen are 201, 200. Okay, so one more 203. So out of all this, they are the same. They are the same clone, same fat lump, same face, same name. Achong, fat achong. Now, so because they're not the same mass, like isotopes not the same mass, I have to find the average name. So average, relative, you know. So average word here because like chlorine. Chlorine is what? Chlorine is 17. Sorry, 17. 3, 8, 17. Okay, got 35 and chlorine what? 37. Yes, 17. So there are two types of chlorine in nature. No, that means you use any Clorox and you put some ice inside, come out all the chlorine in. There are two types, and they found in the world for chlorine. The happening is the amount of this present is about 3:1. 3 more of this. That means average mass. Now this is called the AR now. The relative atomic mass of chlorine. You see now, there are two isotopes there. It's equals to, well, what's the average then? 3 times 35 plus 1 times 37 divided by how many sample? 4 is it? 3 plus 1 is it? But if you work it out, it's 35.5. That's why I got 0.5 here. I don't know. It doesn't tell you, this number doesn't tell you the exact number of proton. We got half proton one, we got half neutron one, isn't it? Okay. So now, of course, you can see that you want me to show you. Okay. Yeah. you don't believe me, your A level, your O levels is humblang lousy, then you don't lah. You should not be taking chemistry A levels like that. Proper chemistry. Okay, chlorine. Upside down, never mind, huh? See now, 35.5. See now. This is the AR. Why? It's the average mass of one atom of chlorine found in nature. In nature got isotopes. In nature play a fool. Okay, now. Can? Alright, so that's why you see, that's what I say here. Because why they ask one here, why is it average? Because there is naturally occurring isotopes in nature. Okay? So now you look at this carefully here. Okay, see, gone already. Never mind. Okay, now let's look at the lens zoom here. Alright? Alright? So average mass of one atom must be one atom more, okay, compared to this one here. Okay? Now, of course, you can, okay, I am going to use the top part here. Okay. Alright. I should have put a few more pages. I'm quite stupid. I'll just learn this today. Never mind. Now, so the second one here, this one clear or one shot one is useless. Direct program, clear one shot. Okay. Now, let's say chlorine now. You see, if we talk about chlorine, right? Chlorine now, from the first idea, I will have, right? I will have AR. Oh, it's not working. Okay. See, AR for chlorine, AR for Cl. Okay. So it's equals to the average mass of one atom of chlorine. Okay? Remember average mass, that means okay already, means okay, over 1/12 times mass of one atom of carbon 12, where carbon 12 equals to 12 units. Exactly. Now, because chlorine has got two isotopes now, Cl35 and Cl37. Okay, remember it's a mass which represents the total nuclear number. So I now well, what do I call this now? If I want to put AR for Cl35, what am I doing? 35 now. 35. So what should I say? I must say, no longer average is the mass exactly of one atom, okay, of the isotope Cl35 over 1/12 times mass, everything the same now, of one atom of carbon 12, where carbon 12 equals to what? 12 units. 12 units. Exactly. Now this is called what? Called relative isotopic mass. Why relative compared to carbon 12? Isotopic because I'm talking about that one particular isotope. Here is average, means of all the type, the two isotopes. I can also have another one, AR. So this AR is no longer called relative atomic mass. It's called relative. This is called what? Relative isotopic mass. So I can have another AR for Cl37. It's equal to what? Same. Mass of one atom of isotope. Cl what? 37 over 1/12 times mass of one atom of carbon 12. Same thing, carbon 12 equals to 12 units. Exactly. See now, so now this, of course, the answer goes to 35. This answer goes to what? It's equal to 37. Now there's no units, no units. Why? Because of the comparison. That means it's 35 times more heavy than 1/12 of carbon 12. You know, no units. No units. Why? Because it's a comparison. Because why? It's a comparison. I'm 100 kilos, you're 50 kilos. That means I'm 2, you are 1. So I'm 2 times heavier than you. So 2 is no units one. Okay, now understand? Understood it? Okay, so this is called the relative atomic mass. These two are called a bit different. They're called relative isotopic mass. Now look at it carefully here. Okay, go back here. Okay, now. So now here, see now, relative isotopic mass of an isotope now is a ratio of the mass. Here, what is different from here and here? From here, it's the mass, but here is the average mass. The word average here is missing. Right, don't have. Why? Because I'm not talking about everybody. I'm talking about one person. One type of fat now. Okay? The mass is the mass of an isotope compared to blah blah blah. Are we the same now? Now, I know time is up, I know, but now let's look at some of the definitions. Okay. First of all, let's look at isotope. Okay, page 28. I hope you got here. This Gundu thing is really driving crazy, you know, so it doesn't move. Where's the Gundu? It's supposed to give me the page, you see? I for myself. See, this thing is ridiculous. No. Okay, page 284. Okay, 284. See, this one we'll learn probably next lesson. Okay, this blah blah blah. See, okay, define the terms relative atomic mass and isotope. Okay, now, okay, relative atomic mass. Remember the first one. Okay, of course, this is for this fellow here called element X. Whatever, don't care. 15 here. See, relative REM is called relative atomic mass, or is AR. Mean, average, mean average same. This is the word average here. No average, no marks. Average mass of the isotopes of the isotope, or average mass of should be of one atom of the element. Okay, just one mass of the isotopes, enough already, right? Okay, relative to or compared to, you can put it in the ratio, no? Because Asians are they lousy English, England very bad. Okay, relative to, see the 1 mark is for the average mass of one atom of the element, 1 mark. Okay, you want to put exactly average mass of the isotopes or average mass of an atom, enough. Okay, preferably okay, 1 atom is the best. Relative to 1/12, the mass of the atom capital, say where exactly they must put these two is 1 mark, no, 1 point here and 1 point here. What is 1 mark? Without this one here, no marks. Okay, very important. You have to memorize it. You're bad in English, you have to memorize it. No choice. You want to do A levels, no choice. Unless you want to do D levels or B levels, you want to, I don't care. No. Isotopes. Atoms the same number of protons, or proton number, or atomic number, all is the same, but different mass number, or number of neutrons, or different number. Same, isn't it? Okay. Now they are very specific. Now let's get relative isotopic number done. Remember, this is for relative atomic numbers. Now there's one for relative isotopic number. Let me just show you. Sorry about this. My throat. Okay, page 288. Come on, number, come on. I don't know where the fella is. 28. See? The number won't come out. Never mind. We look for 28. 28 now. This is down here. 288. Okay. Question here. I see it. Right? Define the term relative isotopic number or isotopic mass. Okay, 2 marks. Right? This is 15 May, June 22. 15 May. Okay, yeah. Okay. B, right? See, it's the mass of an atom. Or mass or one atom of the isotope. So see, what's the difference? There is what is missing here? There's the word relative missing here. Oh, sorry, average here. Don't have. It's the mass of an atom or one atom. Enough already. Of the isotope. Isotope. Relative to blah 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 blah. And see, 2 marks here. Relative to carbon-12, exactly 12. They must put this one here. This one is 1 mark. This is the same as all this one. Relative to 1 over 12 the mass of one atom of carbon-12, where carbon-12 is equal to 12 years exactly. You must put it down. See, when you study, you must study exactly. Don't simply study. Oh, I study already. See, practice don't make perfect. What make perfect? Perfect practice must be perfect. And how do you know what's perfect? Marking scheme. The book's not perfect. The books just tell you what they think only. These fellows are all, they tell all the places. No, because you're sitting CIE and you better see what CIE says. They say dance, say has under dance. 2 steps. Oh, 2 steps, not 3 steps. They say kiss the floor. Kiss the floor lah. You go and do yourself and then you flunk and then you blame everybody. Look at the marking scheme and learn from the marking scheme. Okay, now. So now today we have finished this part here. Time's up already. Okay. So if you want to look at it carefully here, see the stupid thing doesn't come out, the page doesn't come out. I got idiotic. I don't know where to press. See. Anyway, I didn't come out. Let me come on. Let's press. Okay. See here the page now. This thing is giving me trouble. Okay, let's review what we've done. Okay. Okay, here we have talked about atomic, the atomic particles. Okay, electrons, protons, neutrons, and even charges. Okay, and all these things, and of course, how to write the symbol. Okay, carbon is 12 on top, 6 on top. Okay, and whether positive or negative or 0. Okay. We look at the tables we've done there. Okay, now another thing, secondly, we talk about the definition. Okay, what does relative means? Okay, right. I just started on these 2 relative atomic mass, and I started with relative isotopic mass. Okay, now next day or tomorrow, whatever I'm going to do next one is on molecular mass and form mass. I'm going to look at this thing called moles, and of course, these 2 will be next. Okay. Then we go into a lot of calculations. Of course, here we have a definition of empirical formula, molecular formula, and so on. We are going into the area of calculations. So you're bad at calculations, you better pay attention, okay? Otherwise you'll flunk. Okay? So good. I have finished. Thank you for watching. Thank you. Please review, okay? How to remember things. I got only 3 good things for you. You want to remember well, there are 3 steps. Who knows what 3 steps are? I'll tell you. Review, review, review. No other way. The Chinese school do it like crazy. That's why they are quite good in memory. Okay, you think in just one shot, one time look at this, I remember, you are just going to fail. I tell you, I am a prophet, I predict you will fail. Okay? Review, review, review. No other methods. Okay, goodbye and goodbye and goodbye. Okay, I'm going to stop sharing. Yeah, more.